Hey there, math magicians. Here we are again, learning something new. It's always fun to learn something new and face a challenge and overcome. So let's title this Notes, Lesson 11.6. That's where you could look it up in your textbook. And the topic is adding and subtracting rational expressions. So we're going to be adding and subtracting fractions, rational fractions. Alright, so you've learned how to add and subtract fractions already, but now we're going to apply that knowledge to algebra. Okay, so let's jot down some important steps. And I think if you use these steps as a checklist to go through, it should help quite a bit. So step number 1, factor first. Factor first. Okay, I've been saying that quite a bit in this unit. It's very critical in this particular lesson that you do indeed factor first. Look for a GCF, look for difference of perfect squares, look for easy trinomials, look for British method trinomials, and possibly even grouping. Alright, so factor first. Step 2. You must find a common denominator. Alright, so you have to find a common denominator. Okay, so just like when you learned before how to add and subtract fractions, you needed a common denominator, so we still do. We need a common denominator here, and it's going to involve some algebra. Alright, step 3. Simplify each numerator. Simplify each numerator. Okay, this might involve distributing, maybe. So you might have to distribute. You might have to FOIL or double distribute. And that's probably it, that you'd have to FOIL, double distribute, or just distribute. Alright, and then number 4, you're going to add or subtract. You're going to add or subtract like terms in numerators. So you're just going to add up the numerators, because remember, you just leave the denominators the same. So you're going to add or subtract like terms in the numerators. Here's something pretty critical. You're going to have to distribute negatives when you subtract. So distribute the negative if you subtract. And then the only other thing I would say that might be helpful, right up here, when you simplify the numerators, just leave the denominators in factored form. Alright, leave the denominators factored. So let's just put that down here as an added thing. Leave denominators in factored form. The numerators are the only ones you have to do all the work with as far as simplifying. Alright, so we're going to refer back to these steps, and let's go through some examples. Alright? Okay, so maybe we'll only do 3 examples. So here is example number 1. So examples. And here's number 1. 2x minus 1 over x squared plus 2x minus 8 minus x plus 1 over x squared minus 4. Okay, so refer back to your steps, and if you remember, step number 1, factor first. Okay, so you look at each piece. Can 2x minus 1 be factored? No, there's no GCF. It's not the difference of perfect squares. It's not a trinomial. So we're going to leave that one as is, 2x minus 1. And it might be helpful to put it in parentheses. Okay, this is a trinomial. It's an easy trinomial because the leading coefficient is 1. We're looking for two numbers that multiply to negative 8 and add up to 2. So you can do that over here. Multiply to negative 8 and add up to 2. That has to be positive 4 and negative 2, right? Positive 4 and negative 2. So that'll be x plus 4 times the quantity x minus 2. Now, I would leave a little space here. Leave a little space because you're going to have to do a little work finding common denominators. And then minus, all right, this can't be factored. There's no GCF. It's not difference of perfect squares. It's not even a difference. So let's leave that x plus 1. And like I said, it might be helpful to put it in parentheses. And then this is a difference, subtraction, difference of two perfect squares. So I've memorized that. Oh, don't forget the subtraction sign. Right there. Bring that subtraction sign right down. Okay, so difference of perfect squares, x plus 2 and x minus 2. Alright, so that's step 1, factor first. Step 2, find a common denominator. Okay, so common denominator. You're just looking down at the bottom, the denominators, and you're trying to make it common. So this has an x plus 4. This one doesn't, so this one needs an x plus 4 because they need to be common. They need to be the same. So x plus 4 is here. I need one here. So remember, when you find a common denominator, you have to multiply not only the denominator, but also the numerator. So you have to multiply the top and the bottom. Because really I'm multiplying by 1, right? If the top and the bottom, the numerator and denominator are the same, you're multiplying by 1, which is perfectly legal. Multiplying by 1 doesn't make any change. So this had an x plus 4, this one needed an x plus 4. This has an x minus 2. Well, this one already has an x minus 2, so we're set. Those two are the same. All right, now jump over here. This has an x plus 2, and this one doesn't. So this one over here needs the x plus 2. So you multiply not only the bottom by x plus 2, but also the top. Okay? All right, so the common denominator, an x plus 4, an x minus 2, an x plus 2, an x plus 4, an x minus... All right, they're common. They're the same. All right. Step 3. Simplify the numerators. Just the numerators, okay? Don't touch the denominators. Just leave the denominators alone. So the denominator is going to stay x plus 4, x minus 2, x plus 2, minus, and this denominator is going to stay the same. X plus 2, x minus 2, x plus 4. Alright, so don't touch the denominators. Leave them in factored form. But the numerators, you're going to have to distribute or double distribute. So I'm going to have to double distribute this and this one. Alright, so double distribute or FOIL. So here we go. 2x times x, 2x squared. 2x times 2, 4x. Negative 1 times x, negative 1x. Negative 1 times 2, negative 2. All right, now FOIL over here, double distribute over here. X times x, x squared. X times 4, 4x. 1 times x, 1x. 1 times 4, 4. All right, let's see what the next step is. Okay, the next step is add or subtract like terms in the numerators. Be aware that you might have to distribute a negative, so in this case we do. We have to distribute this negative and leave the denominator alone. Leave it in factored form. All right, we're going to get our final answer here. Adding and subtracting like terms, distributing a negative. All right, 2x squared, take away an x squared. 2x squared, take away an x squared is just x squared. All right, here we go. Plus 4x, take away 1x. Plus 4, take away 1. Plus 4, that's 3. Take away 4 and take away 1. So over here we had 3x. Might want to write that down. 3x. And over here we're taking away 4 and taking away 1. So that's like taking away 5. So 3x, take away 4 and take away 1 more. That's like taking away 5. That's going to be minus 2x. And then a negative 2, take away a 4. Not add 4. Take away a 4, because you have to distribute the negative. Negative 2, take away 4. That's negative 6. All over. And just leave the denominator factored. Don't bother multiplying the denominator out. It's extra work that you don't need to do. Alright? And the only thing left to do would be to check the numerator if you could factor. What multiplies to negative 6 and adds up to negative 2? Multiplies to negative nothing. Nothing. So that's done, and there's your final simplified answer. Alright, we'll try 2 more examples. I'll put it on the next video.